Greetings and welcome back. I am Mr. Nagengast. In this video we're going to look at selected solutions from section 5-4 in Pre-Calc, page 404. Number 1, cosine of 120 degrees plus 45 degrees. We will handle that as a sum of cosines, and the formula then will say we take the cosine of the first 120 degrees times the cosine of the second, or you'll recollect it as cosine of u plus cosine of v, where u is our 120 degrees and our v is our 45 degrees. And to that we're going to subtract a sine of 120 degrees times sine of 45 degrees. Now the next thing we need to do is come up with values. And the values for each of these is the following. We have negative 1/2 for cosine 120 degrees. And for the cosine of 45 degrees, we have that square root 2/2. Now subtracting from that, the sine of 120 degrees will give us the radical of 3/2. And, of course, sine of 45 is radical 2/2. Now, simplifying and coming up with the common denominator, well, as luck has it, they both already give us a value over 4. And we can put these two fractions together, leaving us with negative radical 2 minus radical 6/4. Now this is a pretty nice, tight, complete answer. However, we could rewrite that as a negative and then a radical 2 plus radical 6/4. And even further break it down, we could take out of the numerator a radical 2, take the 4 from underneath, and have it as a following solution. Negative radical 2/4 times 1 plus radical 3. So in this case, I personally tend to like the first two, but oftentimes you'll find solutions as the following. And then he gave us at the end. Well, we're going to keep moving along because we want to make these videos as tight as possible and get as many problems as I can done for you. Cosine of 120 degrees plus cosine of 45 degrees. Now, does this deal with the sum and difference formulas? And the answer is no. It is not a sum and difference formula. If you look back up here, the sum and difference formula occurs when there's a sum or difference of angles within the function of cosine. This one, however, is not set up in that fashion. In fact, if 120 degrees was some other value that we needed to break down to a sum or difference, that would be another story. But we do have 120 degrees as a common angle where we can solve. And we know, looking at the above one, that we had solved the cosine of 120 degrees to be this negative 1/2. The cosine of 45 degrees, once again, was radical 2/2. And if we put the two together, a negative 1 plus radical 2/2. Now this is our solution, and that definitely is different than what we had above. Continuing on this page, number 7 says for 105 degrees broken up or split up as a sum of 60 degrees and 45 degrees, solve for sine, cosine, and tangent. Now the key word was and. So for each one of these we're going to need to solve for 3 different functions. And I'm thinking I might need just a little bit more space here. I'm going to grab this one and slide it down a little bit. There we go. Now, for sine of 105, that's what they're asking us to do. They tell us virtually to break it down into this sum of angles. So what is the process that we know? Well, that the sine of 60 degrees times cosine of 45 degrees will be added to the cosine of 60 degrees times the sine of 45 degrees. Again, we're going to use substitution. That's what a lot of these formulas do. We substitute in and then we take out what we can. Well, the sine of 60 comes out to be radical 3 over 2. The cosine of 45 is radical 2 over 2. To that, we're going to add the cosine of 60, which gives us 1/2, and the sine of 45, which is radical 2 over 2. Now, having done this, we're going to put together these multiplications, leaving us with a radical 6 over 4 plus a radical 2 over 4, breaking down to a radical 6 plus radical 2 all over 4. Again, I like the completeness of it, the tightness of this solution. However, you may find it that they take out a radical 2 from the numerator and put that over R4 and then multiply it by radical 3 plus a 1. Now again, that's factoring a 2 out, this square root 2 from square root 6 plus square root 2. Again, you'll notice I'll say square root, or sometimes I'll state radical. It's imperative or very important you understand I'm speaking the same language when I use either one. Now for the cosine of 105, again they have broken it up for us, and so we have the cosine of 60 plus 45 degrees. So this is the second function I'm dealing with because they want all three. The cosine of 60 then will give us the cosine of 60 degrees times the cosine of 45 degrees. To that we are going to subtract the sine of 60 degrees and the sine of 45 degrees. Then we get to the process of substitution, and at this point we should be looking at a 1/2 for the sine of 60, a radical 2 over 2 for cosine of 45, subtracting then the radical 3 over 2 for the sine, and then we'll have our radical 2 over 2 for our sine of 45. Putting these together, we'll end up with something that's becoming very familiar. We end up with a radical 2, this time a subtraction of radical 6 all over 4. Again, don't be surprised to see the function solution written as radical 2 over 4 times 1 minus radical 3. The tangent, of course, is a little bit more complex. Again, we are going to break that up into the two functions they are requesting us, a tangent of 60 degrees plus 45 degrees. There is our sum for the tangent. Now this one is a fraction, and so just keep that in mind as we work this one. Whoa, got a little up there on us. We're going to take the tangent of 60 degrees. To that we're going to add tangent of 45 degrees. That will all be over 1 minus tangent of 60 degrees times tangent of 45 degrees. Okay, that's just reading it right off of my function table or my formula and substituting in tangent 60 and tangent 45. Now I'm going to substitute the actual values for each one of these. The value of tangent 60 will give me radical 3. The tangent of 45 will give me a plus 1. So the numerator looks like the following. Now I will simplify the denominator, leaving me with a 1 minus, and if I look at tangent of 60, which is square root 3, and tangent 45, which is 1, I'll just have a subtraction of radical 3 in our denominator. Now, it'd be nice if we could leave this, but math etiquette tells us we are going to need to rationalize that denominator. So we're going to multiply it by that all-powerful identity of 1, which means I'm going to have a fraction that is equivalent to multiplying by 1. Anything by itself will divide by itself will equal 1, other than 0. And now I will work the problem out. The top looks like conjugate pair. In the conjugate pair, I should end up with a radical. It looks like in this case, we'll get a 1 minus a 3. Oh, my mistake. I mean, these are supposed to be additions. So it's the bottom that I have that conjugate pair right here and here. Sorry about that. So we have a 1 minus 3 in the denominator. In the numerator, if I actually do the FOIL and skip the shortcut, I would end up with a radical 3 plus a radical 9, which of course is going to be 3. So radical 9, which of course will be a 3. A plus 1 as I start to do this part of the distributive property, plus a 1 plus a radical 3. So what I will get in my problem then, as this starts to simplify, is I will end up with a 2 radical 3 plus 4 in the numerator and a negative 2 in the denominator. Of course, we can simplify everything by a negative 2 or factoring out a negative 2, which would give us negative radical 3 minus 2, or negative 2 minus radical 3 in descending order. So our best answer is the negative 2 minus the radical 3 as a complex number. Okay, I think I have a few minutes left, so I'm going to try to just introduce these two to you. We are looking at 19 as sine of 13 pi over 12. So I'm going to want to figure out how I can rewrite 13 pi over 12 as a combination of a sum or a difference. And what jumps out to me at this point in time is to break down this as an equivalent fraction, and the equivalent fractions of 9 pi over 12 plus a then 4 pi over 12. So what I'm looking for is the 9 and the 12 to divide into our 12, or our denominator, which gives me reducibility, and in this case I have a 3 pi over 4 plus a pi over 3. So my new problem looks like this. Sine of 3 pi over 4 plus pi over 3. Starting this for you in the first step, we're going to then get an equivalent function of sine 3 pi over 4 times our cosine pi over 3. Recall that this is giving us a u and a v. And we're going to add to that a cosine of 3 pi over 4 times sine of pi over 3. I'll leave the rest of that for you to solve, because I want to get us a look at 29. Now 29 is in a group where they're asking us to look at a problem and see if we can write that as a sum or difference from one of our functions. Now if I look at this, this obviously will be something to deal with a tangent u, in this case, plus a v. Now what could that u be? Well, if I let this 2x be u and the x be v, does that fit into my problem set? And in fact, it does. What it tells me then is my tangent will be 2x plus an x. That can be simplified down to a tangent of 3x. And